So we're coming up to the last chapter here of the physical science, and it's about organic chemistry. Organic chemistry is the chemistry of life. It's got carbon in it, and it had to be once living. Like in Cole's case, it was old plants and grasses that used to live in a marsh, fell over in the mud, and they didn't have oxygen to decompose, and so they built up these big beds of coal. If it was oil, for instance, those were animals and zooplankton floating from in the surface of the waters, oceans, shallow oceans, particularly where they were teeming. And as they died, they floated down and sank to the bottom, and then they got covered with mud, and then a little bit of heat cooked those up into oil. Generally, they don't dissolve like oil and water, and they burn at high temperatures. They don't just evaporate. They'll sizzle, and they'll like burnt food on your grill. They have low melting points in a lot of cases, like camping fuel. If you ever go out camping, they evaporate really easy, or lighter fluids. They'll have actually a large pressure, so they like to evaporate in spaces like in a car, and that's what drives them. So when we're talking about formulas from organic chemistry, we're going to talk about hydrocarbons, carbon compounds that are just hydrogen and carbon. That's it. Let me make this a little bigger so we can see kind of where we're going. Let's move that way over here. And typically we might see something like C3H8. Now, if you remember from 2 chapters ago, I mean, the last time we were together, C3H8, you put the valence electrons in here and you could draw these covalent compounds. Each carbon has 4 because it's in the 4th column from the right. So it's got 4 valence electrons times 3. That's 12 valence electrons. Plus, the hydrogens each got 8. So that's a total of 20 electrons. 20 electrons these atoms are throwing into the pile and say, hey, let's share these so that we all get our outer shells filled. And if you remember, we just go like this. Yeah, let's throw the atoms down and then put the others around them. That's the skeleton structure, if you remember from the Lewis structures like that. Okay, so there we have our 8. Let me just do this. Oh, come here. I'll erase that one. So we got 20 valence electrons, and we got to get all those atoms happy. So start between them first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and that was our 20 electrons. So that is a good structure. That works as Lewis structure. That's the way these guys all throw their valence outer shell electrons in, and they're made happy. Now, some ways this is what's called a molecular, or not, a structural formula, because it shows the order in which they're connected. As you get bigger compounds, you don't have to connect them all in a straight line, which we'll see in a minute. So sometimes they'll also write these as simpler ways. So notice how this is like, one carbon's got 3 hydrogens on it, and this carbon in the middle has 2 hydrogens on it. So they'll condense these down. This is a condensed formula. A lot of times you'll see that. CH3 just means like this compound part right here. CH2 in the middle, CH3. Now, when they're really going fast, and they want to show these, for big molecules, and they don't want to spend all that kind of time to draw these all out like we're talking about, they'll just show them as bends, and each bend here is a carbon. So, for instance, you may have some big long molecule that you're going to be talking about in the body, and it may have, a bunch of these on here, and so they'll show them very fast by drawing just the carbons. Every bend in there is a carbon, and that's just important to remember because you'll see a few where you'll practice that kind of a method, and that's called the line drawings. Line drawings are used almost exclusively in organic chemistry when we're talking about medicine and those to show bigger molecules because they get all that hydrogens out of the way they're important placeholders, but this is really what's causing all the action. It's the backbone from which all the rest is hung. Now, when we want to name these kinds of compounds, when there's 1 carbon or 2 carbons, every time there's an end of one of these lines, there's another carbon. Notice how these names change. They all have "ane" at the end, and that's because they're all single bonded. So let's go into the naming systems for these. Okay, naming systems are going to be if it's 1 carbon long, you're going to use meth. If you're going to, it's called methane or meth. Okay, that's the only one kind of you can have. Ethane or propane. Now, if they're single bonds, they end in "ane," like we were showing up there. But if you have double bonds, in these cases up here, some of these you might be able to see where there are compounds that have 2 bonds in here, 2 bonds between carbons, okay, or even a triple bond. That's a possibility. Okay, so when those show up, if anywhere in the molecule there's at least 1 double bond, you're going to change the last portion instead of being pent, for instance, for 5 carbons. "Ane," it could have 1 double bond. It's going to be pentene, or propyne if there's a triple bond. So those two are going to work together to be able to add, name those compounds. Okay, so you've got some compounds that are coming up in your first worksheet to practice those names. Good luck.